So, yesterday we talked about having a graph in standard form for absolute value, and we said it looked like this. It looks like y equals a absolute value of x minus h plus k. Yes? Okay. Today you're going to see functions that are written in this form. Nothing really changes. What does the a do? What does the a tell me? What does the a tell me? The a is this part. What does that tell me?
Oh, it depends on if the graph looks like that or that.
Okay, it can tell me if it goes up and down. It also tells me what else? What does that number in front of that graph tell me?
Oh, shrinks or
Yes.
values.
So it tells me if it shrinks or stretches. Okay, so it tells me if it shrinks or stretches. What does h and k tell me? The vertex. Okay, so when you see a function written in this form today, we are doing the same thing. What it is saying is, if I have my a value and I plug in a function of x minus h, okay? So I'm going to plug in an equation probably there, or I'm going to plug in a parent function there. So what is my parent function of absolute value? So we're going to write it this way. The function of x equals the absolute value of x. So over here, I have equations pre-written. I have this graph, and it's at 0, 0, 2, 3, and 5, 3. And it wants me to perform a transformation to this graph. It wants me to perform a transformation of 2 times the function. Okay? Now here's the deal. My function is this graph. Okay? Which means, in this case, I've got to think outside the box a little bit, and I am taking this portion and I am changing it by a unit of 2 times that portion. Okay, 2 times that portion. So if I am changing it by 2 times that portion, okay, what you're going to do is you're going to literally take 2 and multiply it by every y value in this graph to shift it. Okay, so I'm going to multiply it by every y value. That's what this tells me. Okay. Because I am applying that to the function. So here's the deal. When you take a function like we did over here, right? We took whatever was in this and we multiplied it by this, we added it to this, and we got our y value, yes? So when it's already pre-graphed for you, we are doing what it says to the y value so that we can figure out what transformation has happened, okay? So what would be my new points of this graph if I am multiplying the y value by 2? What's my new point here? It's still the same. What's my new point here? 2, 3 becomes 2, 6.
Oh,
I'm only multiplying the y value. Okay? What?
f of x is the same thing as y, right?
Yes.
So y, so basically a says the new y side, or
Right.
the new y
So
equals,
this says a times the y. Yes, because f of x can be replaced with y. So a times the y. Good job. Way to think of it that way. What do I get over here? What's 5, 3 become? 5, 6. Okay? And now look at this. My new graph has been stretched, okay, by a unit of 2. Okay? So Drew is right in what he was saying is because f of x can be replaced with y, it's telling us we're taking 2 times my y value. Okay? Now down here, this one looks different. This says y equals negative f of x plus 2 plus 1, right? Okay, so that looks a lot different, correct? Okay. Now, this tells me something. What does that tell me? Not shrinks. What does the negative tell me specifically?
Oh, it flips.
Yes, true. So I know that this graph here is no longer going to be up here, it's going to be down here, right? It's going to flip it over that y-axis. What does this 2 and this 1 tell me? Okay, so your vertex now is at what?
2.
Not negative 2, 1. Okay. Where is your vertex originally in this picture? What would you think is your normal vertex? 0, 0. Okay? So if I take negative 2, 1 and add it to 0, 0, what becomes my new vertex? Negative 2, 1.
Wait, you said if you add.
Yes, because I'm going to have to change everything by adding these points to the other points. So I get negative 2, 1. Okay, that's my new vertex. Does that make sense right there? Okay. Take 0, 0, I add negative 2, 1 to it. What happens when I take negative 2, 1 and add it to 2, 3?
0, 2. Oh, wait, my bad, yeah.
Yes, it would be 0, 4, right? 0, 4. Okay, it would be 0, 4, correct? Okay, what happens when I take negative 2, 1 and add it to 5, 3? It would be 3, 4. Okay, 3, 4. Now, I know this isn't what my graph should look like because I know it should be what?
Flipped.
Flipped. Okay? So this is my axis of symmetry because this is my vertex. I have to flip everything over that axis of symmetry and mirror it. Do you get what I'm saying here?
Yes.
Okay? So if I do it this way, it's easier than trying to add all these steps at once because that gets confusing. Okay, so if I graph this way first, then I can go ahead and just take this new graph and translate it over. So this here is 1, 2, 3 points away from that axis of symmetry. So 1, 2, 3, that's the new point. So my new point is 0, negative 2. My vertex, right, is negative 2, 1. This point is also 1, 2, 3 away. So 1, 2, 3, and it becomes here, right? So this point is 3, negative 2. And now I have graphed this transformation. Do you see how that happens? Okay, so on your homework tonight, when you are graphing and translating things, okay, on one of the problems, it says here's this diagram and it gives you 3 points. Recopy that diagram and then translate accordingly, okay? The first one's easy because it was multiplying and that was the only thing I was doing, okay? And I was multiplying 2y because it says f of x. Here, I had a lot going on. I know it flips, but I saved that to the end because I applied this to the vertex first and went from there, okay? The last thing we need to be able to do on our homework tonight is to look at an equation that is graphed and come up with the equation for it. Creating the equation of this graph. Okay, we know the equation says f of x equals what? For absolute value. A
times x.
X minus h plus k. So if I can find the vertex and plug it in, I can then eventually solve for a or what or whatever. Okay? So what is my vertex of this graph? 2, yeah, 2, negative 1. 2, negative 1 is my vertex. Now, in order to solve this, you have to have on these pictures and on these diagrams, you have to have another point. They have to give you at least 1 point. Okay, here they gave us this point of 3, negative 2. So I have a point that is 3, negative 2. With that information, I can plug this into h and k, I can plug this into y and x and solve for a. Okay? So where is my y technically? The f of x. So I'm going to take negative 2 and I'm going to say negative 2 equals, I do not know my a. What is my x? What is my h?
2.
2. And then what is my k? Okay, -1. I can plug that in, so now all I have is an a to figure out. Process that for a second. What does that mean? That means if I have all that information, I can solve for a, and then I can take a and my vertex and create an equation at the end. Okay? So I solve from here. -2 equals a times the absolute value of 1 minus 1. Absolute value of 1 is 1, so then 1 times a is a minus 1, like that. Yes? Okay. I add 1 to both sides, and you get a equals -1. So my equation should say f of x equals negative absolute value of x. My vertex was -2, -1. That's how you create an equation off of a graph. So you can't just stop once you find out a. You have to plug a back in and plug the vertex back in. Okay?
What's
Yeah.
f of x equal?
What?
The answer. So f of x equal.
So f of x equals negative, because I don't have to put a 1 there. I can just put a negative sign for my a, because a is -1. If a comes out to equal just 1, you don't have to put a 1 there. You can. I won't count it wrong, but you don't have to. You can just put absolute value of something in mind. Okay? So those are the 2 things you're focusing on tonight. You're focusing on shifting and stretching, shrinking, flipping. And then you're focusing on, here's a graph, let's create an equation. So when you look at a graph, you have to be able
Please
to
excuse
recognize
this
the
interruption.
vertex.
I need the following
And a
8th
point.
grade students to come to the front lobby: Daniel Inman, Seth Michaels, Joshua Turner, Carter Woolard.